Yeah, good evening, everyone. So, in last class, we have studied about what we have studied about. Yeah, anyone can answer. We have studied about issues in distributed operating system. Next, limitations. Next, we have studied about synchronization. Yes or no? The next, what is Christian algorithms? Christian algorithm is the simplest algorithm for setting time. Okay. Here the client is sending the request to the server. So initially the time is T naught. Then server is here, the server is, what is the name of the server here? Yes, time server. Then after some time the server is sending the reply to the client. Here the distance between T naught and T1 is known as waiting time. Then here the time taken by the server delay in the time is known as interrupt handling time. Both T naught and T1 are measured with same clock. Here we are measuring both T naught and T1 time with the same clock. Okay. What is the new time here? T new equal to T server plus T1 minus T naught divided by 2. Is it clear, ma? So the distance between the T naught and T1 are measured with the same clock and it is known as waiting time. Next is Berkeley algorithm. What does it states? What is the meaning of this algorithm? Yeah, okay. The server polls each machine periodically asking it for the time. The server asks the time, the machines which are present under it asks for the time. Okay. Based on the answer, it computes an average time and tells all the other machines to advance their clocks or slow down their clocks until some specific reduction has been achieved. Okay. Based on that, it will ask based on the situation. So the time demons must be set manually by the operator periodically. By seeing this diagram, we can understand. So this is the times demonstration. Sorry, actually I was on mute. So what the time demonstrates, based on the, it will first ask all the clients their timings. Based on the answer, it will compute the average time and tells all the other machines to advance or slow down their clocks until some specific reduction has been achieved. Okay, initially time demons ask the time with all the machines. Even it will adjust the server time also. Let us consider it as server. Then these are clients. It is client 1, it is client 2. Initially the server time is what? 3 o'clock. Client 1 time is what? 2:50. Client 2 time is what? 3:25. So they are connected with a network. Then next, see the time demons ask all the other machines for the clock values. The next what all the machines will, the machine will answer. See, based on that it will try to modify the clock. So for 3 o'clock it is not doing anything. For see, to make it as 3 o'clock, what it is doing? See, here 10 minutes is less. Here 25 minutes is extra. Then to make all the times, to synchronize all the clocks, what it is doing? So it is making all the machines time as 3:5. To make the server time 3:5, what it is doing? It is adding the 5 minutes. For here, it is adding 15 minutes. Here, it is reducing, subtracting 20 minutes. So now all the clock timings is same. All the clocks are synchronized. So here the time demons tells all the machines how to adjust their clocks. Is it clear, ma, this diagram? Please answer soon. Why? Because meeting is for only 30 to 35 minutes, I think. Is it clear?
Yes, ma'am.
Okay. Okay, next is Lambert's logical clock. What is the meaning of logical clock? Suppose if two machines do not interact, there is no need to synchronize them. Yes or no? If two machines are connected through network, if they are communicating, then we need to synchronize them. If two machines they do not interact at all, then there is no need to synchronize them. Then what is the important? The process here in logical clocks, order of event is important. It does not give much preference to the time. Absolute time is not important. Okay, here we don't follow the concept of happened when. Okay, when it is happened, just we need the execution or order of event need to be completed. It will assign some numbers to the order and it will check whether this order of events are completed or not. Okay, irrespective of time. See here, event A happened before event B. So happened before notation. So this is the arrow mark is known as happened before notation. So here A and B both are the events. So event A must happen before the event B. Is it clear, ma? So here processes will exchange the messages. Messages must be sent before receiving. Yes or no? First message will be sent, then it will be received. Okay. See here, see. Happened before relation. In a machine, if two events are taking place, event A and B, event A occurs before event B. Suppose event A is occurring at 3 o'clock. Event B may occur at 3:30. If you are sending message to someone, it will take some time to deliver. Yes or no? So event B occurs after event A. Timestamp of an event must be always less than the event B. Timestamp of A event must be less than the event B. Then only it is considered. Okay. Then only it is considered as a good order event. See here. TS of A, transitive relationship. Here. TS of A, TS of B. This is the happened notation. Happened before. So TS of A happened before TS of B. TS stands for timestamp. Then next timestamp of B happened before timestamp of C. Okay. The next timestamp of A happened before timestamp of C. Casually ordered relationship. C. A happens before B. Okay. What is the meaning of concurrent event? Concurrent event. What is the meaning of concurrent event, ma?
Two or more events happen at the same time, ma'am.
Okay. Concurrent event states that it is not necessary that event happens one after the another. It can happen simultaneously. Okay. Then let us consider one example. See, here we are considering three processes P1, P2, P3. Okay, A, B, C, D, E, F, G, H, I, J, all these are events. Okay, P1 process contains how many events? Consists of A, B, C, D. See, these questions I have given assignment. So that's the reason before sharing the assignment, I am explaining. If you know the explanation, you can solve by yourself. Okay. So here A, B, C, D, E, F are the events. In P2 process, how many events are present? 3 events. G, H, I. In P3 process, how many events are present? 2 events. J, K. See, according to the events, we are giving them value. See, A is 1, B is 2, C is 3, D is 4, E is 5, F is 6. Here, for next process, we are starting from 1 again. G is 1, H is 2, I is 3. Again in the process 3, we are starting from 1. J is 1, K is 2. Is it clear, ma?
Yes, sir.
Okay. Then next, if A and B are the two events in the sum process, then A need to be occur before B. See what is good ordering? If A value is 1, B value is 2. A value must be less than the B value. Then it is known as good ordering. Here also see B value is less than C value. Here C value is less than D value. Then next here D value is less than E value. What is bad ordering? Observe here. See how we are considering the values. See what is the meaning of E? See from E to H. So here E value is 5, H value is 2. So what does ordering event states? LHS value must be less than the RHS value. So here it does not satisfy the condition. So it is a bad ordering. Is it clear, ma? Is it clear?
Yes, ma'am.
Let us consider one more example. So here we are considering three processes. Three processes have different clocks, different timings. Okay. See here the clock values are 0, 6, 12, 18. So different interval of time it is following. Then process 2 is following different interval of time. 0, 8, 16, 24, 32, 40 like this. Then third process is following what? Different clock. 10, 20. Okay, different interval of times it is following. Initially we are sending a message from M1 to process 1 to process 2. So it is satisfying the condition. Consider this value as A, this value is B. So A value is less than the B value. So it is satisfying the condition. Then next, from process 2 to process 3, we are sending the message. Here the A value is 24 and the B value is 40. So this is also satisfying the condition. Yes or no? Then next M3, from process 3, we are sending to process 2. So here A value is 60, B value is 56. Is it satisfying or not, ma? This condition?
No.
Yeah? It is not satisfying. Okay. Then we need to apply Lamport's algorithm. Okay. Here also we are sending from here M4 we are sending from 64 to 54. It is also not satisfying. Consider it as A and B. A value must be always less than the B value. So next what we are doing? So here the value is 60. Here the value is 56. So we are adding plus 5. If we add plus 5 to 56, then the total is 61. For 64 plus 5, 69. For all the remaining values, we need to add the remaining values or remaining interval of time which is available in the process. We need to add some certain value. So for 72, if we are adding 5, then its value is 77. For 80, if we are adding 5, then its value is 85. So it is updated remaining timings. Here we are updating the remaining timings. For next process, what we are doing, it is 69 and 54. We are adding what? Plus 16. So the value changes to, if we add 54 plus 16, 70. If we add 60 plus 16, 76. So here we are adjusting the process 1 values. Why we are adjusting, ma'am? Why we are adjusting these values? Anyone can answer? to synchronize the clocks. Yes or no? Then next, vector clocks. What is the meaning of vector clock, ma? What is the meaning of vector clocks? So vector clock means if two process communicates, we check which process occur first and later. Then we will compare the timestamp values. According to the higher or max value, the timestamp value will be updated. Okay. Initially, the timestamp value will be 0. For any event, the timestamp value will be 0. Let us check with an example. See here, check this figure. See, initially, see here we are considering three process P1, P2, P3. Initially, all the process values are 0. Why we are taking three values? Why we are taking three values, ma? Are you able to hear me?
Yes, ma'am.
Why we are taking three values means here we are using three processes. If you are taking two processes, you can take two values. If you are taking four processes, you can take four values. So here we are taking three values. So initially for all the three processes, the values will be zeros. Then this is the event 1. For event 1, process 1, presently we are in process 1. So the first value is 1, 0, 0. P2, P3 value is 0. Then event 2, 1 is completed now, second. So 2, comma 0, 0. Event 3, 3, comma 0, 0. Okay. Here we are not communicating with any of the nodes. The next for P2 process, it is P2, so P1 value is 0, P3 value is 0, P2 value is 1. Okay. Here what we are doing here, see, P1 and P2 is communicating with each other. So we need to compare the values. Okay. So middle it will be 2. Again we need to compare these two values. Which is maximum we need to take. So initially this value will be 0. So we are comparing these two values. The maximum value is 2 here. So we are taking the 2 value. So here it is 0. Here is a 0 we are taking. Is it clear, ma? If any process are comparing, first we need to extract those values and we need to compare those values and we need to write one updated value. Are you able to understand? Initially this value will be 0, 2, 0. So 0, 2, 0. So 0, 2, the value will be 2. 2 is maximum, so we are taking 2. So second value is 2. Then third value is 0. Then next, how we are communicating for this? So if we got here 2 value, we will write 2 only. Okay. Is it clear, ma? Wait, I'll explain again. Initially, this value is, what will be the value for this initially? 0, comma 2, comma 0. Why? Because it is processed 2. So the middle value will be 2. We will compare this. 0, 2 means, so maximum value is 2. We are writing here 2. Again 0, 2 means maximum value is 2. Last one is 0. Okay. Then for this, what will be the value? First we'll write one value. After comparing, we'll get this value. What will be the initial value first? As we got the value as 2 here, so the value will be 2, comma 3. So it is the third event, no? So it will be 3, comma 0. These values. So what is the process 3 event 1 value? 0, 0, 1. Here P1, P2 will be 0. Then third value is 1. Then we are comparing these values. See, initial value is 0, 2 means the value is 2. Again 0, 3 means the value is 3. Again 1, 0 means the value is 1. So below is the updated value. This is the initial value. So we have to compare this, and this is the updated value. This is the initial value. Next, what is the initial value for this? So what will be the initial value for this one? 2. It is the fourth event, no? So the second value will be 4. P4. Then 1 as it is. Okay. Then we are comparing. What is the value for this? Bit confusing, but it is easy only. If you understand, it is easy. What is the initial value for this? So it is the fourth event. Okay. Then P2 is 0. P3 is 0. Now we are comparing. See, 4, 2. So 4 is maximum. We are getting 4 here. Then 2, 4, 0. So 4 is maximum. We are getting 4 here. 1, 0. This is the updated value. This is the previous value. 1, 0 means we are getting 1 here. Then next for this is the fifth event. 1, 2, 3, 4, 5. So first one is 5. Then P2, P3 value we will write as it is. Okay. For this, P1 value is 2. P2 value is 5. Why? Because it is the fifth event. P3 value as it is we will write. Then for this P3 process, P1, P2 is 0, 0. P3 is 2. As it is not communicating with any other events, so the value remains same. Is it clear, ma? Did you understand this vector clock? Initially, all the process values will be 0. This why we are taking 3 values means there are 3 process in the system. All these greens, all these are events. Everything is event. What is the black dot means? These are communicating events. These are normal events. They are not communicating with anything. Is it clear, ma? So what is it clear or not? You need to answer. Based on that, I will decide I need to proceed or I need to explain again. Just you try to do it by yourself once, you can understand clearly. If you have any doubts again, you can ask me in the class, okay?